Another day, another story. Electromagnetic waves have become an integral part of our lives, powering everything from our smartphones to the vast array of electronic devices we use daily. These waves were discovered through a series of experiments conducted by scientists throughout history, who were fascinated by the relationship between electricity and magnetism. In this article, we will explore the history of electromagnetic waves, their discovery, units of measurement, the people behind them, and their applications today. History and discovery. The history of electromagnetic waves dates back to the early 19th century when scientists began to experiment with electricity and magnetism. In 1820, Hans Christian Oersted, a Danish physicist, discovered that an electric current produces a magnetic field. Soon after, André-Marie Ampere, a French physicist, showed that two parallel wires carrying electric currents will either attract or repel each other, depending on the direction of the currents. In 1831, Michael Faraday, an English scientist, made a crucial discovery that led to the understanding of electromagnetic induction. He demonstrated that an electric current could be induced in a wire by moving a magnet near it. This phenomenon laid the foundation for the development of generators and motors that we use today. The next significant breakthrough in the field of electromagnetic waves came in 1864 when James Clerk Maxwell, a Scottish physicist, published a set of equations that unified electricity and magnetism into a single theory of electromagnetism. These equations predicted the existence of electromagnetic waves, and Maxwell concluded that light is a form of electromagnetic radiation. The first person to prove the existence of electromagnetic waves was Heinrich Hertz, a German physicist, in 1887. Hertz was able to demonstrate the production and reception of electromagnetic waves in the laboratory. He generated radio waves using an oscillator, and then detected them using a simple circuit of wires and a spark gap. This experiment was a significant milestone in the history of communication, paving the way for the development of radio, television, and other wireless communication technologies. Units of measurement. Electromagnetic waves are measured in terms of frequency and wavelength. The frequency is the number of waves that pass a given point in a second, and it is measured in Hertz, Hz. The wavelength is the distance between two consecutive peaks or troughs of a wave, and it is measured in meters, m. The relationship between frequency and wavelength is described by the equation, c equals lambda f, where c is the speed of light, 299,792,458 meters per second, lambda is the wavelength, and f is the frequency. This equation shows that as the frequency of a wave increases, its wavelength decreases, and vice versa. The people behind electromagnetic waves. The discovery and development of electromagnetic waves were the result of the work of many scientists throughout history. 1. Hans Christian Oersted discovered the relationship between electricity and magnetism in 1820. 2. André-Marie Ampere demonstrated that two parallel wires carrying electric currents attract or repel each other, depending on the direction of the currents. 3. Michael Faraday discovered electromagnetic induction in 1831. 4. James Clerk Maxwell published a set of equations that unified electricity and magnetism into a single theory of electromagnetism in 1864. 5. Heinrich Hertz proved the existence of electromagnetic waves in 1887. Applications of electromagnetic waves. Electromagnetic waves have numerous applications in various fields. Some of the most notable applications include: 1. Communication. Electromagnetic waves are the foundation of wireless communication technologies, such as radio, television, and mobile phones. 2. Medicine. Electromagnetic waves are used in medical imaging techniques such as X-rays, magnetic resonance imaging, MRI, and positron emission tomography, PET.